image processing and computer vision techniques. So what you see here is essentially for a towel, the robot is trying to identify the diagonally opposite ends of a towel so that it can hold it up. So it performs these motions. It's just trying to straighten the kinks out. It drags it across the table to do this. And then now it knows that the end that's left is essentially the other end of the piece of cloth. So it goes in, grasps it and holds it out. So it has to go through these bunch of motions, because then clothing could be in infinitely many configurations, right? And so it wants to make sure completely autonomous. Yes. So it's doing the vision, the perception.
And it knows that the piece hasn't flopped over.
So it's figuring that out on its own. So it's doing these motions to try to get it to a particular configuration. So once it gets here, it brings into the second phase. So the second phase is what it's doing is it's essentially trying to lay it out flat on the table so that then it can go in and start folding. So to do that, it first in the initial phase it first got hold of the two diagonally opposite ends of the cloth. Now it gets hold of 2 points along a single edge, right? And so it's straightening it out. And then it'll bring it down on the table, and then it'll lay it out. And again, because the robot has no knowledge of what the cloth's doing and what it would possibly do, what the surface is, then it starts straightening it out. So then, right now you see that it's not completely flat. So any fold that you attempt with this will not succeed. So then it comes in, and then it'll flip it over.
It's like watching a child.
So yeah, so now it's laid it out flat, and so that's essentially this phase where now it looks at the article and figures out, this is the configuration that I'm dealing with. Now comes the hard part of how do you actually fold this thing, and this could be a towel, this could be a shirt, this could be a sweater, it could be anything. And so you could perform a bunch of motions to try to fold this thing. So the approach that we came up with is a geometric approach instead of a physical one. So the idea is the robot always does motions where part of the cloth is horizontal and part of it is vertical. Now this is a restricted set, but then you can plan for motions and how to fold it, and this is rich enough to work for shirts and skirts and sweaters and trousers and even onesies. So yeah. So it's doing the planning on the fly. I mean, there wasn't. So there's no hand-coded motions here, because you possibly couldn't do that with cloth. And that is one of the things that we're trying to do. Variability, where even if you try recording motions and playing it back with variability like this in deformable objects, it will fail. So then now it goes ahead and folds it. Well, that's it. Okay. So